Welcome back to my channel. In this video, we will create a mysterious and incredibly fascinating simulation in Blender 4.3, designing a mystical crystal ball. This simulation will utilize Blender's particle system, which, while quite complex, will yield surprising results. Let's open your Blender and get started right away. First is the concept phase. I will create a transparent crystal ball containing a glowing core, where Blender's particle system will generate glowing particles that I'll use to produce the magical effect for the crystal ball. Once generated from the core, the particles will move chaotically and collide with the walls of the crystal ball. The simulation will be set up so that only a small number of particles escape, while the majority remain within the crystal ball, continuing to oscillate chaotically inside. As a familiar step, we need to delete Blender's default cube. First, I will create the crystal ball. Add an icosphere and press F9 to open the adjustment menu of the newly added icosphere. I will set subdivisions to 8 to further subdivide the faces of the icosphere. Next, right-click on the icosphere and select Shade Smooth, and now we have a perfect sphere to use as the crystal ball. Since the next design steps will involve working with the interior space of the icosphere, I will go to the Viewport Display option in the Object settings of the icosphere and set Display as to Bounds. Note that this will display the icosphere as a cube frame in the viewport, making it easier to observe objects inside the icosphere, but it will still render as a normal sphere. The next step is to create the core of the crystal ball. Add a new icosphere. This time, there's no need to set subdivisions to 8 again, as Blender has saved the default subdivisions value of 8 from our earlier adjustment. Next, right-click on the newly created icosphere and select Shade Smooth to smooth its surface. Then, press S to scale the new icosphere to a ratio of 0.1. At this point, the smaller icosphere will be located at the center of the crystal ball and serve as the core of the crystal ball. If you have explored Blender's particle system, you'll know that it allows you to generate particles from various sources, including forming particles in the shape of a specific object. In this simulation, I will use this feature of Blender's particle system to create particles with a uniform shape, small spherical particles. To achieve this, I will duplicate the core icosphere of the crystal ball and move the newly duplicated icosphere outside the volume of the crystal ball. This duplicated icosphere will serve as the template for the particles generated in the simulation. To avoid confusion during the simulation setup, I will rename it Object and rename the crystal ball core to Emitter. Now it's time to configure the necessary settings for the simulation. First, I'll configure the crystal ball. For particles to collide with the surface of the crystal ball, we need to set the crystal ball as a collision object. Select the icosphere, the crystal ball, go to the physics settings, and select collision. In the collision settings, pay attention to the permeability option. This option allows you to adjust the ability of objects to pass through the surface of the collision object upon collision. Set permeability to 0.01 to ensure that only a small fraction of the particles passes through the crystal ball's surface upon collision. You may also be interested in the stickiness setting, which adjusts the adhesion of other objects to the collision surface upon impact. In this simulation, I'll set stickiness to 0 because I don't want the particles to stick to the surface of the crystal ball after collisions. Next, I'll configure the core of the crystal ball. Select the emitter, go to the particle settings, and click plus to add a particle system to the emitter. Take note of the emitter settings below. Start with the number setting, and set the value to 1 million, thereby adding 1 million particles to the particle system during the simulation. Note that the larger the number of particles, the longer Blender's computation time will be, requiring a more powerful computer to handle the simulation. Set the frame end value to 2. With the default frame start value of 1, this means particles will be generated in the first frame and stop being generated at the second frame. The purpose of this setting is to ensure that all particles are generated within the first 2 frames. Next, to ensure the particles persist throughout the simulation's 10 seconds, 300 frames, set the lifetime value to 300. Concurrently, adjust the total frames of the simulation to 300. Then, configure the velocity of the particles at the moment of generation. I don't want the particles to bounce too far from the surface of the emitter upon generation, so I'll reduce their initial velocity to 0. Scroll down to the render section and set render as to object. As mentioned earlier, this setting will generate particles in the shape of a specific object. First, set the scale to 0.002, meaning the particles will be 0.002 times the size of the selected template object. In the Instance Object section, click the picker and select the template object. Naturally, I'll choose the previously designed object. Continuing downward, you'll find the Field Weights section. Here, set the gravity value to 0 to ensure that the particles are not affected by gravity. My intention in this simulation is for the particles to float inside the crystal ball rather than being influenced by gravity and settling at the bottom. The above settings will cause particles to form from the core of the crystal ball. However, to direct the particles' movement, we need to add a turbulence force field to the environment where the particles exist. Go to the physics settings to configure the turbulence parameters. You can adjust the strength, size, and flow values to suit your preferences. Through experimentation, I found suitable values and will set strength to 4.9, size to 0.18, and flow to 2.2. Don't forget to enable absorption so the turbulence force field is absorbed by the collision object, which is the crystal ball in this simulation. Now it's time to create shaders and lighting effects for the objects in the simulation. First, I will add a glowing effect to the particles and the core of the crystal ball. Begin by switching the shading mode to rendered so you can observe the exact colors and lighting of the objects. You can also disable overlays to reduce visual clutter. In the viewport shading settings, set the compositor to always so any changes in the compositor are always displayed. This is crucial because in Blender 4.3, glowing effects require the use of the compositor. Add a new window and open the compositor in it. Here, enable Use Nodes to work with the node-based system in the compositor. At this point, you'll see two default nodes in the compositor. Insert a glare node between these two default nodes. In the glare node, set the glare type to fog glow to create a soft glowing effect that simulates light scattering in fog. Then, set the quality to high for the best visual results. Next, open the shader editor window. Since the particles are formed based on the prototype object, I will select the object to create the glowing shader for the particles. Click New to add a new material to the object. In the principled BSDF node, set the transmission weight to 0.5 so that the particles, when formed, are not solid objects but allow light to pass through, creating a more ethereal effect for the particles. Next, go to the emission setting, adjust the object's color as desired so that the particles emit light with the same color, and increase the strength to 2.5 to enhance the glowing intensity of the particles. Avoid setting this value too high to prevent the particles from being overly bright. Finally, hide the object from the viewport and renders, as the object is only used as a template for the particles generated in the simulation and does not need to be visible in the viewport or renders. I'll take the opportunity to delete the light to better observe the particles glow in the simulation. You can re-add the light later if needed. Now it's time to create a transparent glass material for the crystal ball. This is quite simple. Select the icosphere, click New to add a new material. In the principled BSDF node, reduce roughness to 0. Next, set IOR to 1.45, which is Blender's default value for glass materials. Don't forget to go to the transmission setting and set the weight to 1 to allow light to pass through the glass easily. The next step is to add a material for the core of the crystal ball, the emitter. Again, click New to add a new material for the emitter. For the emitter, I will only create a glowing effect for it without allowing light to pass through it like the particles. Therefore, I will only adjust the color and strength in the principled BSDF node of the emitter, using the same color as the particles but with a higher strength of 4. This ensures that the emitter emits light with a color consistent with the particles while having a higher glow intensity, as it is at the center of the crystal ball where the particles are generated. Finally, go to the particle system settings of the emitter. Under the cache section, select Bake All Dynamics to bake all frames of this simulation. This step allows Blender to calculate all aspects of the simulation and save all frames into a cache file, enabling you to render your simulation video with ease. The baking process can take quite some time, depending on the complexity of the simulation and your computer's specifications. Now, let's see what we've got. Thus, my tutorial on designing a mystical crystal ball in Blender 4.3 has come to an end. I hope you find this guide helpful and inspiring for your own projects. If you have any questions or suggestions, feel free to mention them in the comments section below the video. Don't forget to like, share, and subscribe for more tutorials like this. Thank you for watching, and see you in the next videos.